continuing. This is the last set of the quadratic functions and their graphs. Go ahead and read this problem, push pause, and then try to solve it. And then if you can't get it, go ahead and continue on. We're going to have 3 problems in this section. Okay, for this type of problem, the best thing to do is write an equation to represent the scenario, and drawing a diagram might be helpful. So first we want to write the expressions to represent the dimensions of the pool. So we let W equal the width, and the length is 2 feet less than the width. So W is the width, L is the length, and so it says the length is 2 feet less than twice the width. So 2 less than twice the width. The area of a rectangle is length times width. So we're going to have length times width. Oops. And our length is that. So we have 2W minus 2 times W. Now set this to the area. The area they said is 480, so that equals 480. And then we have a quadratic situation. So we have, I'm going to go ahead and do this part first. This is going to be 2W squared minus 2W equals 4, or minus, I'll go ahead and put equals 480 here. Equals 480. Since it's quadratic, we're going to move everything over to the left here. And factor. You factor out, this was 2W, I forgot. So factor out of 2. You get W squared minus W minus 240 equals 0. So we have 2 times W minus 16 times W plus 15 equals 0. So our W equals 16 and our W equals negative 15. It can't be negative, so we have to disregard the negative 15. And this means the length must be, if this is the width, the length must be 2 times the length equals, I'm going based off that, 2 times 16 minus 2, and that equals 30. So now we have to add an extra foot around the edges to represent the fence. So let's go ahead and kind of draw this. We have the rectangle here. And I'm going to draw, this is supposed to be a rectangle. So basically we have, this is 16 here, and this is 30. And what we're doing is we're drawing a foot extra around. So here's the foot extra around it. Okay, so this is like an extra foot here, and from here's extra foot. From here there's an extra foot. From here there's an extra foot. From here there's an extra foot. From here, you see where all the extra feet go, okay? So this is extra foot. So we have all these extra feet here, because this length here is 30. And from here to here, it's 16. Or we can put it over here. So basically, the dimensions, the new dimensions for the pool is 16 by 30. But for the fence, if you add a foot, you're adding actually 2. Because you're adding this and this. So it's going to be 18. Well, we're adding, sorry, for the 16 we're adding these 2. And then we're adding 2 here for the 30. So by 32. Now, to do the perimeter then, we're going to have 18 plus 18 plus 32 plus 32, which equals 100. And was this a multiple choice? Yeah. So the answer is 100, which is what? Answer B. Okay. And the next one we have, if k minus 4 is a factor of this quadratic equation, k is a constant, what's the value of k? So basically, you could substitute each of the answer choices in for k and factor, but this will use up a valuable time on test day. Instead of think about what it means for x minus 4 to be a factor. So if x minus 4 is a factor, then this x squared minus kx plus 2k, can be written as something like x minus 4 times x minus some a. Alright, so what I want to do is go ahead and factor this out, and we get x squared minus 4x minus ax plus 4a, and then which also can be written as x squared minus, and I'm going to factor out an x here. So it's minus x times 4 plus a, and then I have my plus 4a. So basically, remember this equals x squared minus kx plus 2k. So I know my k, my a here for this one has to be, let's see, if we do that, the two quadratics are equal only if 4a, let me do this in red, 4a equals 2k. And then we have also that 4 plus a equals k. So we have 4 plus a equals k. So what we do is we have a system so we can substitute. And we substitute, we can get 4a equals 2 times my k. And my k is what? 4 plus a. So we get 4a equals 8 plus 2a. So 2a equals 8. So a is 4. Now if a is 4, I'm going to plug it back in to my original. So the question asks for the value of k. So k equals 4 plus a. We already have that here. So I can just plug in my 4, so k equals 8, which is answer C. You know, think about this one and maybe do it again a little slower. Okay, the last one we have of the hard ones is the sum of the roots. And roots are the same as solutions to an equation. So you don't need to solve the equation for x. Don't let the fraction intimidate you. And don't jump to any conclusions that you need to find the common denominators. Notice that adding 1/2 to both sides of the equation will actually eliminate the fractions. So basically I can add 1/2 to both sides. This cancels, so I'm going to get 1/2 x minus 2 squared equals, this is going to be 6/2, which equals 3. So, and I think this is supposed to be 1/3. I must have written this down wrong. This is supposed to be 1/3. Sorry, guys. Alright, now, so we have 1/3 x minus 2 squared equals 3. And then we're going to multiply both sides by 3. multiply this by 3, and this side by 3. So we get x minus 2 squared equals 9. And then both sides are now perfect squares, so just take their square roots of both sides. And when you do that, you're going to get x minus 2, don't forget your plus and minus, equals plus or minus 3. So we have x equals plus or minus 3 plus 2. I'm going to break that up. So that's going to be 3 plus 2, which equals 5, and negative 3 plus 2, which equals negative 1. So, how come? So basically, we get that. And the question asks for the sum, so we're just going to add these up. 5 minus 1, or 5 plus a negative 1, and that equals 4. So that's all. Thank you and have a nice day. Bye-bye.